Okay, so I'm going to be explaining how to find the least squares line. So what that is essentially, it's a minimization of the sum of the squares of the vertical distances from the generalized points to the line. This line is represented just by y equals mx plus b. We have some generalized points here, and from the point to the line we have our residuals, and this is given to you by the difference in the y coordinates. So it'd be y coordinate minus mx plus b. Mx plus b in the general form is the y coordinate for each of these points on the line, and these are all squared. To find the next part, you take a sum of all of those square differences, and as you can see, we have our first residual, second, third, fourth, and so on, all the way up to the nth. This is the function of bm, and it's just representing, this is the general form of the summation, and then next to it we have what it's equal to, all the way up to n, the nth term. So to minimize f, what we have to do first is take some partial derivatives. So we take the partial derivative of f with respect to b. Please excuse my space here, but as you can see, you use the chain rule to take partial derivatives of each of these squares, and you end up here, and then you're able to factor out the 2, and you just get this general form. Here is the differentiated form of the overall the equation with respect to b. And then we do the same thing with respect to m. Same process, you factor out the negative 2, only this time because of the chain rule we have the negative x term coming out, and this is the final form of that. The next thing we do is create a system of equations. So we set this equal to 0, rearrange it in this case to essentially be y equals mx plus b. We do this for each of our partial derivatives, and then we solve this system of equations. So you go from here, you solve for b, plug this into equation 2 I sloppily marked here. So we're going to go ahead and plug b in right here, and this is what you end up with. You distribute this term through. You get rid of the denominators by multiplying everything by n. It clears it up to look like this. Rearrange everything so you have all your m's on one side. Then you factor out the m, and to isolate the m, you then divide both sides by this expression, and it leaves you with m equal to this. Now we go back to equation 1 and solve it for m this time, as you can see up here. And we basically do the same thing where we plug m into equation 2 from number 4, and it's more or less the same process. You end up with this, you distribute this term, clear out the denominators by multiplying everything by the summation xi. Please excuse my summation notation. Anyways, then we go ahead and rearrange to get b on one side, all of our b terms. Then once again, we factor out b, and we end up with this. And we divide, and we end up with b equals this equation here. A couple of properties that came in handy was the summation of a constant. B is a constant, so when you sum b, you end up with nb, which is just the number of times you are summing. At least that's how I understand it. So our next step was to evaluate m and b at these points here, 1, 1, 2, 1, and 3, 3. I went ahead and made this chart to represent n. We have 3 for 3 points. We have our xy for each point. We have our xy for each point, and then our x squared for each point. And then to evaluate, we just summed up all of our x terms. So 1 plus 2 plus 3 is 6. 1 plus 1 plus 3 is 5. And so on. That way we can take our EX, for example, plug it in here. Our YX would be this term. Our x squared would be this term. Not to be confused down here. This would be our x, our summed up x term, which is 6 squared. This would be our x squared term, which is 14. And then n would just be filled in by 3. I will show you the calculation. After evaluating b and m, I discovered that the least squares line is y equals x minus 1/3. And just to show you the calculation, it was this here. It was just Desmos. I just plugged in those terms in their respective places, ended up with b equals 1/3 and m equals 1. Hopefully you were able to see that. And yep, that is it. Thank you very much for watching.